Hello, this is Mrs. Taylor, and I'm going to walk you through how to solve a differential equation. So to start with, you need to know what a differential equation is. An equation involving a derivative is called a differential equation. So anytime you see dy over dx equals, or f prime equals, or y prime equals, that's called a differential equation. And to solve a differential equation, you integrate. And so if the directions say solve the differential equation, all they really want you to do is integrate. So when we're integrating, if we don't have a definite integral, so a closed interval that we're integrating on, you include a plus c in what we'll call your solution. So your antiderivative including a plus c, and this is called the general solution. And then sometimes, depending on the setup of the problem, they'll give you an initial condition. And if that's given, you use that condition to solve for the c value and provide a particular solution. And so the antiderivative with plus c is called the general solution, and this represents the family of functions that are the solution to the differential equation. And your particular solution is just one of those solutions where you have solved for c. So let's look at an example problem. In the directions it says find the general solution to the exact differential equation. So all you have to do is integrate your equation. Now if you integrate dy over dx, integrating a derivative, there are inverse operations, so you're just left with y. And then on the right hand side you can integrate the terms individually. This first term you would use power rule, add 1 to the exponent, that'd be 5, divide by 5. The 5 divided by 5 would become 1, and you would end up with x to the 5th. And then the integral of secant squared x is tangent of x. So your general solution would be y equals x to the 5th minus tangent of x plus c. So you include that plus c to represent the fact that there could be a constant there, and when you took the derivative, the constant equaled 0. Now let's look at a scenario with a particular solution. In this example, the directions say solve the initial value problem explicitly. So when you see that word, explicitly means that you have one variable solved for in terms of the other. So typically in algebra we have y solved for. And so we have our differential equation dy over dx equals 2 times e to the x minus cosine of x, and our initial condition of y equals 3 when x equals 0. So all this means is we integrate and then plug in our initial condition, solve for c, and then put that into your solution. And so if I integrate 2 times e to the x, the integral of e to the x is just e to the x, and you have this constant of 2, so that carries over into your antiderivative. And then the integral of cosine of x is sine of x. And so your general solution is y equals 2 times e to the x minus sine of x plus c. And then you use your initial condition to solve for the c value. So you plug in plug in 3 for y, 0 for x, and that would look like this, where you have 3 equals 2 times e to the 0 minus sine of 0 plus c. And if you simplify this, 2 times e to the 0 would equal 2 because e to the 0 is 1, and sine of 0 equals 0. So you have 3 equals 2 plus c. Subtract 2 from both sides, and c would equal 1. So your answer will be your general solution, but with the c value plugged in. So it would look like that. Y equals 2 times e to the x minus sine of x plus 1. And so that's how you would find a general solution and a particular solution when asked to solve a differential equation.